Number 18, a particle moves along a circle in a region of uniform magnetic field of magnitude 4 milliteslas. The particle is either a proton or electron, you must decide which. It experiences a magnetic force of magnitude 3.2 times 10 to the negative 15 newtons. We have to first figure out the speed, then the radius of the circle, and then the period of motion. Well, we know the force must be acting towards the inside to keep this thing moving in a circular path. And you could go ahead and try a proton. If the proton's moving this way, it would define the current as going this direction. And with the magnetic field pointing out of the board, current field force, you would discover that the force, using the right-hand rule, will be pointing in the opposite direction. What does this mean? Well, it means that we actually must be dealing with an electron and not a proton. With an electron then moving in that direction, we would actually define the current as going this direction. And again, if you do the right-hand rule, even though the velocity is this way, you would discover it would produce an inward force. So how do we figure out the speed? Well, we can use the force on a charged particle moving magnetic field is equal to QV cross B. In this case, we know the force. The charge on an electron, 1.6 times negative 19th coulombs, and the field, 0.004 teslas. Again, that's a millitesla, 1 or 4 thousandths of a Tesla. If you solve this for velocity, you'll discover it's moving 5 times 10 to the 6 meters per second. That's pretty doggone fast. That's 5 million meters per second, but still within reason, it's less than the speed of light. Part B. What's the radius of that circle? Well, you might say, wait a second, how do we do a circular motion? Well, in this case, we know that this force, due to the magnetic field, I'm calling it F sub B, must be providing the net inward force necessary to keep it going in a circular path. That's the centripetal force, F sub C. We know this force from up here that was actually given. The force to the magnetic field, that's got to equal the centripetal force, mv squared over r. Yes, you have to look up the mass of an electron. The velocity we have from the previous question, 5 million. If you solve that, then you'll discover the radius is 7.12 times 10 to the minus 3 meters, or 7.12 millimeters. Pretty tiny, but not unreasonable. Finally, part C, what's the period of the motion? Well, there's a couple of ways of doing this. I'm going to go with the simplest. Since we know velocity, velocity is just equal to distance over time. The distance it travels going around this circular path once is 2 pi r, the circumference of a circle, divided by the time it takes to go around once. Well, that's the period. Plugging in our numbers, we know the velocity is 5 times 10 to the 6th. We know the radius is 1.12 times 10 to the minus 3rd from the previous answer. And with that, we can find the period. The period is about 9 times 10 to the minus 9th seconds. Crazy short, which gives us a frequency, the reciprocal of that, of close to 10 to the 9th, or a gigahertz. And yes, this is the way that microwaves and many microwave transmitters generate microwaves, just putting electrons in really tight circular orbits. I hope this helps. Good luck.